All right, the first thing to make sure of is you are in degree mode. So when you turn on your calculator, anytime you're doing a problem for this class, okay, check and make sure on your display right here at the bottom line, it says DEG. If it says RAD, you're going to get the wrong numbers. Okay? And if I give you a multiple choice test, the answers that you would get if you're in the wrong mode will always be one of the distractors. Okay, so make sure your calculator is set to the right mode or you will guarantee miss the problem, even though it seems like you got the right answer.
How do you set it to that mode?
If your calculator says RAD, what you need to do is hit this mode button. It's right below the white alpha key. Scroll down 3 spots till where it says angle and change that to from radian to degree, okay, until you see that it says DEG. Now, if you use a calculator online, I'm not sure how the defaults are for that. I think it's defaulted to degree, but I'm not 100% certain. You're probably not going to use radians until you get into pre-calc or calculus.
How do you get to the one online?
The one online, if you go to the classroom folder, I think it's like a O drive or something. Is it U drive?
Yes.
Okay, so go to the U drive. So go to Explore. If you right-click on the window symbol, you can choose Explore, or the window symbol in the bottom left corner. Or right-click on it. Open the folder one. Explorer. There you go. Okay, so under Class Drive, if you look under the classroom folders, and then Department, or Math, and then My Name, and then TI Emulator, open until the very last one, and it's the executable application file. It's like second to the bottom. It says VTI. And just choose Run, and you'll pull up what I'm using too. Go ahead and hit. There you go. All right, so once you're in degree mode, there's 2 different cases of using this. You're either going to use it to find trig ratios or to find angles. Okay, if you're finding trig ratios, okay, what you're going to look to do is the following. And this is probably what you would most likely have done in the past. If you wanted to evaluate the trig ratio for the sine of 47, what it's asking you is, it's asking you to find what is the ratio of the opposite to hypotenuse, opposite side to hypotenuse, in any right triangle with a 47-degree angle. Okay? And so using your calculator for this winds up being pretty simple. All the trig ratios are along this first line of the letters here, the x, y, z, t line. And so if you hit second function y and type in 47. Now, if I don't put anything after this, if I just hit enter, I'm in exact mode, so it's not going to give me the decimal form. You'll usually evaluate trig ratios to 4 decimals. Okay, and I'll specifically tell you, usually with angles, you'll evaluate it to the nearest whole number. Okay, so if we're looking to evaluate this, we either need to hit the green diamond button. That guarantees that your answer is in decimal form. So here I get 0.7314, again rounding to that 4th decimal place. Or I could have also just put a decimal point in my answer, in my display, and that would give me my answer in decimal form as well. Okay, so choose one of those 2 things. Okay. Also, if you are using the calculators on the computer, you can adjust the size of it by putting your cursor along the side and just dragging it out, and you can make it larger so it fits more of your screen. Okay, so I want you just to really quickly, on your own, find the cosine of 47 degrees and the tangent of 47 degrees. Make sure that you can do those, please. is second function z, 47. Again, oops. Hit the green diamond or decimal, put it into the decimal form, 0.68. Now, when you look at this, the way that this one has to round, you can't put 1/9 because the 9 gets rounded to the next one up, which bumps everything. So what you would need to put for that problem would be 0.6820. And then finally the tangent, second function t, 47. Again, you could put a decimal if you'd rather do that than hit the green diamond key, 1.0724 if you round it to 4 decimals. Again, notice there's no restriction on tangents. It can extend from positive or from negative infinity to positive infinity. Okay, so what these are actually representing. So when you see something that says the sine of 47 equals 0.7314, what that's actually saying is if you take any right triangle and you measure off an angle of 47 degrees, it's telling you that the ratio of opposite to hypotenuse, that A over C, has to be 0.7314. So you can find what that ratio is. You know that that has to be true in any triangle, right triangle with an angle of 47 degrees. And so that's where these calculations come from. Again, back when I was in school, these were one of those things that you just had a table in the back of the book that had all of them listed. So the fact that the calculators can give you these is a huge time saver. Okay, now the other thing that you will need to do with this is to identify a measure of an angle. Okay, so if that's the case, you're going to use what are called inverse functions. The inverse functions are located right along the same line. It's just the green diamond instead of the second function. And the inverse functions allow you to find what angle has a specific trig ratio. And the way that those will look is they'll have a power of -1. So it'll look like sine to the -1, but really what that's saying is inverse sine. So that's how I'll refer to it. So if it says the inverse sine of 0.9945, in order to evaluate this, again, you're just typing it in as it appears. So you take the green diamond y, the inverse sine of 0.9945, and when you do that, you get your angle, which usually you'll round to the nearest whole number. And so this one winds up being 84 degrees. Okay, I want you to see if you can evaluate the following as well. For inverse cosine, 0.9781. Hit enter. You get approximately 12 degrees. And then finally, if we hit the inverse tangent, so green diamond t of 0.5317, hit enter, we get an angle of approximately 28 degrees. Okay, so again, what this is identifying is, it's saying that if you have a right triangle, and let's say here's angle x and side x and side y, and let's say this is the angle theta. What it's saying is